you remember the form, all we need to look at is the derivative of the denominator on top. That's what we need to look at.
Yes.
So I think here no adjustment is required, it's on top. So clearly the answer is ln of the denominator. Let's do this. ln 6 minus ln 3, which I believe is ln 2. ln 6 minus ln 3 is ln 2. 6 divided by 3. Log a minus log b is log a upon b. One square. Oh, yeah, sorry. This is ln 2. This is ln 2. Yeah. If you're okay with this part, then we can move on to the next one. Okay, here a little bit of manipulation is required. So either you can use cos A minus B identity and open this up and get a simplified form, or what you can do is, what I recommend is use this. There are two concepts that you can use. Cos of minus theta is equal to cos theta, and cos of 180 minus theta is equal to minus cos theta. If you remember this, you have this in your trigonometry notes, you have these identities with you. This is from P1 trigonometry. So can we use this to simplify the denominator? Try it out. You can use that, but this will be better. You will get one single term. I'm searching for a single term actually. So how about we say sine 2x upon, so the denominator, can I write the denominator as cos of minus 5 minus 2x? Can I write this? And then can I use this cos of minus theta is equal to cos theta? Can we do that? So this will be sine theta. So cos of minus theta is cos theta. Is that okay with everybody? Cos of minus theta is cos theta. And then how about we use this? Cos 180 minus theta is minus cos theta. So what would this become? What was cos? Minus cos? Minus cos 2x. Perfect. So then means this comes down to sine 2x upon minus cos 2x. I'd like to have a minus sign here. Is that okay if I keep the minus sign in the numerator? Now do we have the form? Not completely. What's the differential of cos 2x? Minus sin 2x? Minus sin 2x? Upon the differential of cos 2x is minus sin 2x into 2. Minus sin 2x into 2. So I think the only thing missing is a multiplication of 2. So if I can just multiply the 2 here and keep a half outside, then I think I do have the form with me. So now what would be the answer for the integration? The outside half comes as it. What's the answer to this integration then? Now we have the complete form with us. What will be? Half ln cos 2x. Yes. Do we have limits? Yes, we have limits. Okay. So you get calculations. I think this is a mistype. Your pi by 3 should be on top and pi by 6 should be on bottom, but it's fine. We can just, let's just go with it. So when you plug in limits, you get ln of cos pi by 6 minus ln of cos 2 pi by 3. This is pi by 3. Check. Are we getting this? Now there's another thing to realize over here, by the way. Cos of pi by 3 is a half. So this is ln half. Cos of 2 pi by 3, by the way, is a minus half. Now, if this mod sign was not there, you would have gotten into trouble because ln of a minus half doesn't exist. Now do you know why I've been putting a mod sign throughout? Whenever you do the integration and the result is an ln, you have to put a mod sign because you never know what kind of limits might come in. So see, right now it's supposed to be a minus half, but because of the mod you are saved and it becomes a half. So ln half minus ln half is a 0, so I guess the final answer is 0. Are we all good? Any questions? Shall we move on? Okay, this is just an extension to this concept. Just want to show you something. Okay, now if you are integrating this, and by the way, you have done integration of this, a similar one. I'll just show you. You have done a similar one here. Part D. dx upon dx plus 4. You've just done this. Now, how is it different from this one? Dx upon dx plus 4 whole square. What is the problem that the whole square is creating? The problem that the whole square is creating is this. Your form, the form that we follow, the fraction form says that your entire denominator's derivative should be on top. Which if I just write an f with the dot, that means powers everything included, the whole package. Now if I take the power as well as part of the function, and if I differentiate this, my answer is 2 times ex plus 4 into dx, which is definitely not this. So currently we don't have the fraction form. Can we see that? We don't have the fraction form. Now, but if you notice something, the stuff to notice over here is this. You don't have the fraction form. But if you didn't have this whole power, if it was just the inside, you would have had the fraction form. Do we agree on this? If the whole power wasn't there and it was just the inside, you would have had the fraction form. Because the inside's derivative is e to power x, and that you have on top. It is only the whole power which is creating a problem. So when you come across a situation like this, you need to convert your fraction into a product. And how you do that is you take the denominator out. So I'm going to look at it this way. E to power x into e to power x plus 4 power minus 2. Now, why have we made this into a product? Now, what advantage are we getting by making it up and making it a product? The advantage is this. Do you remember the product form 2? Product form 2 says this. Integration of any function, it may be having some power, but that function's derivative is right next to it as a product. We did this in integration 2. The answer to this is take the function, add 1 to the power and divide by the power. Tell me something, if I look at it this way, isn't the inside function's derivative right next to it as a product? Right next to it as a multiplicator. So this is right now product form 2. It was not fraction form, but when I take it up, it becomes product form 2. Which means the answer is simply take the function, add 1 to the power, divide by the new power, and you have your answer. So it was not a fraction form. Because of the whole power, it was not a fraction form. But if the whole power is only the problem, then you take the denominator out, make it into a product, and then you will notice that it conforms to product form.
So what is
Minus 2 plus 1. Add 1 to the power and divide by the new power. Yeah. Are we good? No. Okay. Let's try another one. Now see, if you take the entire denominator, the derivative is not x squared. The derivative is half times x cubed minus 1 to the power minus half into 3x squared. It's definitely not an x squared. So now it's definitely not fraction form. But the stuff to notice is this. The inside of the whole power in the denominator conforms to fraction form. The derivative of x cubed is a 3x squared. Except 3 ka we are missing. I can always put the 3 and put a 1 upon 3 outside. That's not a problem. The point that we're trying to make is with the whole root, it's not fraction form. But if I forget about the whole root and just look at the inside, it's fraction form. Which means that how do we need to deal with this problem? We need to convert the fraction into a product. We need to take the denominator up. Now you have product form 2. The derivative of this function is right next to it as a multiplicator. it conforms to fraction, conforms to product form too. So the answer is just take the function, add 1 to the power, divide by the mean power. So I guess now we can just do the simplification. Are we good? Any questions? Any confusion? Okay, let's try this. RC is left. No, it's just a numbering for this is part. Okay, now see, if this power 6 was not there, this was perfect fraction form. The derivative of sin x is cos x. Now it's only because of the whole power 6 that we have a problem. Again, this calls for the situation where you convert the fraction into a product. So take the denominator out. Now is it product form too?
Yes.
Derivative of sine is a cos, no adjustment required. So the answer is straight away add 1 to the power of the main function and divide by the main power. Are we all good?
Sir, sir, if you got sin x in the denominator, so can't you multiply cos x with sin 5x?
If this was not what?
We got sin x over here in the denominator.
Okay.
So in the numerator we can add sin 5x.
No, you cannot bring in a variable. You can only adjust constants, you can't adjust variables. Oh. See, this is the same situation. Yes, I'm going to look at it as 1 by x over ln x whole square. Now see, it's only again the power that is making a problem. If it was just ln x, you would have taken the derivative of ln x, it would have been 1 upon x, you would have given your answer as ln of ln x. But because of the whole power, it's not conforming to the fraction form. Which means you need to take the denominator up and you need to look at this way. Now the derivative of ln x is right next to it. So clearly the answer is going to be ln x to the power. You will add 1 to the power and divide by the power and put the limits. So it's basically minus 1 upon ln x equals 4 1.
It's just 4 into
4 into, sorry. So what's the answer? Minus 1 upon L4 plus 1 upon L2. To be exact, this is the answer, but you can do it in decimals. Minus
1.8.
Let's check are we getting this in decimals.
Minus 0.71.
What's the answer? Minus plus.
Plus.
Any questions? Shall we move on? Oh, now, for fractions, the very first thing you will need to note, does it conform to this fraction form? If it does not conform to this fraction form, then that's a kind of an extension that you need to look at. We've already discussed that the whole power is making an issue. But let's say all this doesn't work. Somehow the denominator's derivative is not on top. Now, what the last resort that you will try out is partial fractions. And there are other ways as well, but they will not give you such a function which either they will give you such a function which will either be conforming to form 1 or it's going to be something that you can split with partial fractions. So if form 1 doesn't work, then you try the partial fractions. So first I'd like you to try part AP. Now see, it's very tempting to split into partial fractions because you can see the exponents 1, exponents 2. But I'd still like you to first try out the fraction form. If fraction form doesn't work, then we will split into partial fractions. If the fraction form does work, then we don't need it. So is the fraction form working?
Yes.
Yes, it works. See, this is integration of 2x minus 3 upon x squared minus 3x plus 2. And I think the derivative of the denominator is on top. No adjustments required. The derivative of the denominator is 2x minus 3. We don't need to split into partial fractions. We can do without it. The answer is simply ln of the denominator plus c. So let's say you forgot to check that whether it's of fraction form or not, and you did split into partial fractions, still no worries. Even if you split this into partial fraction, at the end you will get this answer. So you don't have to worry about it. But you should always try fraction form first. Okay, part B. Does it require any fraction form or any splitting is required?
So 3 is right. But 3 is right.
Even before the fraction form, can you think of a way of just doing it directly? I think this can be done directly. Can anyone recognize and see if this can be done directly?
Minus common layer.
Take minus
Minus
common
common layer
cancel.
form.
Maximum minus one cancel.
And yes, see, I can always look at this. So I can take the minus 1 common and becomes this. See, this cancels out. You come down to this, which is minus 10x.